Dart skill presents graphs. In this video, we are going to talk about a few types of graphs. Bar graphs show data as a set of bars. The length or the height of each bar is proportional to the actual number the bar corresponds to. Let's look at an example. A survey among a group of people to find out which was their favorite books was done. Draw a bar graph to show the below given data. And here comes the actual data. On the x-axis or the horizontal axis, we should have the book name, Animal Farm, The Hobbit, Romeo and Juliet, Hamlet, and others. And on the y-axis or the vertical axis, we are going to have the number of people who have voted for each of these books. And here comes the graph. So we have 4 bars. This is one bar. This is another one. And this is another one. And here's the 4th one. Each one representing a book type. And there's actually another one. There you go. So we have 5 bars for the 5 books. The first one is for Animal Farm. I'm not sure I have the space to write the full name, so I'm just going to go with the initials and write down AF out there. So this stands for Animal Farm. And because 4 people had said that this was their favorite book, you see this number 4 out here. So this bar represents the number 4. Similarly, for The Hobbit, it's the same number 4, so we have a bar of the same length. Whereas for Romeo and Juliet, if you look at this bar, it's more than double the length of each one of these two. And the reason is because this number out here for Romeo and Juliet is more than double of 4. And that's exactly why we say the bar lengths or the heights are proportional to the actual numbers. So this one's for The Hobbit, and this one's for Romeo and Juliet. And then this one is for Hamlet. The number is 7. It's less than 9, but it's still way more than 4. So that's Hamlet. And finally, for other books, the number is 5. It's less than 7, but it's more than 4. And that's what determines how big or how long this bar is going to be. So this is for others. A line graph connects the data points using straight line segments. It is usually used to display data that changes over time. Let's see an example at work. A baby is weighed each week at the clinic and the mass in kilograms is recorded in the table on the clinic chart. And here comes the chart. We have the week on the first row. So this is the 0th week, the 1st week, the 2nd week, the 3rd week, and so on all the way up to the 9th week. And here comes the weight of this baby in kgs. 2.1 kgs, 2.1 kgs, 2.2 kgs, and so on. And there are 3 parts. Let's look at the first part. Draw a line graph to show these data. This shows the data in the form of a table. We need to show the same data on a line graph. And here comes the line graph. On the x-axis, we have the week number. So this is the week. And we have data for 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. This is the 9th week. And then on the y-axis, it's the weight. Weight in kilograms. And then the rest is just about plotting the points. So we have 0 on x, 2.1 on y. This point represents 0, 2.1. Similarly, we have 1 for x and 2.1 for y. It's this point, and so on. And after you have plotted the data, you want to join them with line segments. Note that it may or may not be one single straight line. even if you cannot have one single straight line, the idea is to join consecutive points with straight line segments. Now let's look at part B. The baby was sick 1 week. Which week was it? Why? Well, if you look at the numbers on this chart, the weight of the baby keeps increasing, or at least stays the same, except for the 6th week. The weight has actually gone down from 2.5 in the 5th week to 2.3 kilograms in the 6th week. So we would say the baby was sick in the 6th week because the weight of the baby has gone down. And then use your graph. So we are supposed to use this, not the table above, to estimate how much the baby weighed at 3 weeks old. So you want to find the corresponding value of y when x is equal to 3. So we have 0, 1, 2, 3. When x is equal to 3, y is equal to 2.3. So we would say this is 2.3 kilograms. That's how you would create and read a line graph.